Okay, so let's look to solve this analytic trigonometry equation. Cosine squared of theta minus sine squared of theta plus the sine of theta equals 0, where my angle is between 0 and 2 pi. Right? Inclusive of 0, exclusive of 2 pi. So let's remember our Pythagorean identities because we see a cosine squared and a sine squared here. We want to be careful about those, right? We know one identity is sine squared of theta plus cosine squared of theta is equal to 1. If we rearrange and solve for sine squared is 1 minus cosine squared. And if we rearrange for cosine squared, we could say that the cosine squared of an angle is going to be equal to 1 minus the sine squared of that same angle. Okay. So what can we do with this? Well, notice that I have a cosine squared, a sine squared, and a linear term sine. So linear sine, quadratic sine squared, quadratic cosine squared. Okay, so I'm going to want to get things in terms of my linear term. So I'm going to use the substitution. I'm going to use the substitution that the cosine squared of theta is 1 minus sine squared theta. So I'm going to be able to make that substitution and say 1 minus sine squared of theta minus sine squared of theta plus sine of theta is equal to 0. All right? And all I did was make that substitution from the cosine squared, and I replaced that with 1 minus sine squared. Okay. If I group my terms, that gives me 1 minus 2 sine squared of theta plus sine of theta equals 0. Okay. Rearranging my equation, I can say that that is 2 sine squared of theta minus sine of theta minus 1 equals 0. I just multiplied everything on both sides by -1. I don't like for my leading term to be negative, right? But you could leave it if you don't mind negatives. Okay. Next, we'll do our u substitution, right? And we're going to say let u equal the sine of theta. So that's going to give me 2u squared minus u minus 1 equals 0. Okay. Now I have this quadratic form. I could solve the quadratic form by either using the quadratic formula. So I could say, hey, u is equal to opposite b plus or minus the square root b squared minus 4ac all over 2a. I could use that. Or if I'm more comfortable, I could use the quote-unquote box method. Right? I could think about this in terms of areas. Right? I could say, okay, so I'm going to have a 2u squared area here, and I'm going to have a -1 area there. And I'm going to need to consider, right? Right? If I multiply 2 times -1, I'm going to have -2. So I need to consider factors of -2 that have a difference of 1. Right? So of course I'm going to have 2 and 1, and the 2 will need to be negative because now -2 times 1 is -2, but -2 plus 1 is -1. So what does that mean for me? That in one of these corners I need to put a -2u, in the other corner I need to put a positive u. All right? And then I can look to see, okay, well, what are my common factors here? Well, between 2u squared and u, my common factor is u. And then u times 2 is 2u squared, and u times 1 is going to be u. So u times 2u, 2u squared, u times 1, positive u. And then my common factors down here, right? I might not have one, so I say 2u times what equals negative 2u. And that would be negative 1. And I need to verify that negative 1 times 1 is negative 1. And that works. All right? So using that factor method, I can say that u minus 1 times 2u plus 1 is going to be equal to 2u squared minus u minus 1, and I need to solve for that being equal to 0. Well, the solutions here would be u needs to equal 1, or u needs to be negative 1/2. However, we need to remember the substitution. Here we let u equal sine of theta. So that means that the sine of theta needs to equal 1, or the sine of theta needs to equal negative 1/2. Right? If I think about when the sine of theta is equal to 1, I know that that's up at 90 degrees, or pi over 2. And if I think about when the sine of theta is negative 1/2, I know that that's going to be in the third or in the fourth quadrant with the reference angle, and I know that the reference angle for the sine ratio of negative 1/2, or really just the sine ratio of 1/2, that is going to be an angle of pi over 6. All right, so what does that mean for me? That means for me that I'm going to have theta needs to be equal to pi over 2, or theta needs to be equal to 7 pi over 6, or theta needs to be equal to 11 pi over 6. And those would be my solutions between 0 and 2 pi, which the original problem asked for, right? What are those solutions between 0 and 2 pi? Okay. Well, let's just double check to see that those solutions are correct, right? So I can turn on my calculator, and I could come over and I could just double check, come to y equals, clear out my previous equations, and I have the cosine function squared minus, and look at the use of parentheses, the sine function squared plus a sine function, and I need to figure out when does that equal 0. Okay, now I'm looking on the interval from 0 to 2 pi, so I want to make sure that 0 to 2 pi is my interval, right? And maybe I'll look between negative 3 and positive 3 on the y-axis, set my graph, and I can see I have 1, maybe 2, then another, and let's see if there's any more solutions. So it does seem like I've got solutions. It does seem like I have a solution here, as well as here and here. Well, what would those solutions be? Well, if each of these tick marks is pi over 2, right? Pi over 2, pi, 3 pi over 2, 2 pi, right? I set my tick marks, my x scale, to be pi over 2 to make it easier to read. Right, well, I can see that there is an intersection, it seems to be at pi over 2, and then a little bit past pi, and then a little bit short of 2 pi. And there are my solutions, 7 pi over 6, 11 pi over 6. Right? I could, of course, calculate those with my calculator. Second, calculate what's the intersection, right? And I could come close to where my points of intersection are. Press enter once, enter twice, enter a third time. See if I can find a point of intersection. And it says, oh, 1.570. All right, well, let's verify. What is pi over 2? 1.570. And so we have our solutions. All right, so for this problem, here are my solutions.